My name is Marie Schultz. I am the Associate Vice Chancellor for Development here at the University of California, Riverside. Today's event is sponsored by the Watkins Society. The Watkins Society is a visionary group of supporters who have committed gifts to UCR through their charitable estate and trust planning. These alumni, faculty, parents, and friends share a vision for building the university's future and ensuring UCR's prominence in research and teaching for generations to come. To all those members of the Watkins Society joining us tonight, thank you for your loyal support of UCR. A few housekeeping items before we begin. You as the audience can see us, but we cannot see you and you cannot see each other. If you have questions, please submit them by clicking the Q&A button on your screen. Questions will be answered as time permits at the end of the interview. Our interviewer for today is Holly Ober, Senior Public Information Officer in the University Communications Office at UC Riverside. This is the final interview in our three-part summer series highlighting the diverse research of several of UCR's more recent endowed chair appointments. Endowed chairs are one of the highest academic awards that the university can bestow on a faculty member. Endowed chairs both honor the named chair holder and provide an enduring tribute to the donor who established the chair. Tonight, we will welcome Professor Zhiyun Qian, who is the Everett and Imogene Ross Term Chair in Computer Science. Before we invite Professor Qian to share his remarks, I would like to acknowledge the generosity of the late Everett and Imogene Ross and the Ross family, who partnered with the Department of Computer Science and Engineering to establish two new endowed term chairs with a gift to UCR from their estate. Everett and Imogene Ross were both native Californians and lived in Riverside for many years. As community members, they valued UCR as an important resource and institution of higher education in the Inland Empire. They held a strong belief in supporting and enhancing opportunities for learning in the region. Imogene and three of their children, Patricia, Barbara, and Howard, all attended UC Riverside. Everett and Imogene Ross felt strongly that enabling students to complete their education at UCR would increase the likelihood of them staying to work and raise families in Riverside, therefore contributing to the ongoing economic and civil vitality of the region. We are very grateful to Everett and Imogene and their family for helping to establish two new term chairs in one of our fastest growing departments. Now, it is my pleasure to introduce Professor Zhiyun Qian. He received his PhD in 2012 from the University of Michigan. He joined UCR in July of 2014 after 2 years in industry at NEC Labs. At the Marlin and Rosemary Bournes College of Engineering, he's built a highly productive and prolific research program in areas of system and network security. The techniques he applies include program analysis, reverse engineering, fuzzing, model checking, and machine learning. He's worked on protocol security, operating system security, Android security, binary analysis, network infrastructure security, censorship evasion, and web privacy. More recently, he's developed a passion for building systems that result in long-lasting real-world impacts. Professor Qian is an active partner in graduate student recruiting and mentoring. He is helping the Department of Computer Science and Engineering grow and build a core strength in cybersecurity. Earlier this year, Professor Qian was recognized for his exceptional work and appointed as the inaugural holder of the Everett and Imogene Ross Term Chair in Computer Science. Thank you, Professor Qian, for being here today.
Hello, Professor Qian. It's nice to speak with you again.
Hi, thanks for the introduction. Hi, Holly.
So let's get started with our conversation. I opened up the wrong document here. What has your professional journey been like in getting to UCR?
Well, it's interesting. In the very beginning, when I was an undergrad student, I never thought I would do a PhD, just because of the commitment that I have to make. Decided to do a PhD last minute because I didn't feel like the work that I was doing back then in the industry during my internship would be interesting and impactful enough. Um, so I got my PhD from University of Michigan, and then I never thought I would, become a professor. Um, it's terrible work-life balance, from what I can tell, working with my advisor. Um, but still went with it after 2 years of experience in a research lab in the industry. And ultimately, what makes it happen is that it's simply too tempting to be able to work on problems that really interest me. And so here I am at UCR, a great platform that I feel lucky enough to take advantage of and be able to establish a vibrant research group. And in terms of how I got to do cybersecurity as my main research area, I actually accidentally stumbled upon it during my PhD and immediately fell in love with it. I never really had any experience of research or exposure to security prior to it. But when I look back, I think it all makes sense because security requires a certain mindset, specifically the adversarial mindset. And I knew that I had that mindset when I was a kid. I guess I can talk more about it if I get a chance to introduce my research. But that's roughly how I get here.
Okay. What does the support from this endowed chair allow you to accomplish that you might not otherwise be able to?
Well, that's obviously there's a very big recognition, being able to receive this endowed chair, and I really appreciate that. There's going to be probably um, uh, various things that are not directly measurable because of it, and then also there's this flexibility that comes with the fund, which would allow me to explore new research topics if I wanted to. For example, if I wanted to purchase some equipment or some devices, this could come in handy. Um, and and if I wanted to travel to a new conference, perhaps unrelated to my current research area, to learn something new and to be able to make connections to other people, this fund would also facilitate that. In fact, in a security community, it's a very unique situation where we not only have a vibrant academic security community, we also have a very large hacking community in the industry, which is sort of parallel to the academic world. And I personally enjoy making the connection to the hacking community where we can talk to people who are working on similar problems and very similar mindsets, but really with different perspectives. And they often have interesting ideas, methods, and we can bring back the inspirations that can further my research. So being able to do all of that, is really something that can benefit me in the long term. And I think the endowed chair would definitely help with that.
In your mind, what value do endowed chairs bring to universities?
I think the biggest advantage, I guess I see, is that it would help with attracting and retaining top faculty members in the university, which will eventually translate to better reputation and even better ranking. Speaking of which, I just heard that UCR got a good bump in the latest US News ranking. And hopefully we can keep this momentum, and the endowed chairs will hopefully play a role, right, in that.
Yeah, I think they will. So now I'm going to ask you to talk about your research interests. You've already mentioned several interesting things, and this is your chance to expand on all of that. And I'm curious to what you're going to tell us.
Okay, so I guess I'll try to share my screen. Yeah, can you see it?
I can see it.
Okay, so I guess just a little bit of background on how I perceive security problems. You know, I tend to make this connection from security to games, because really any man-made rules can be viewed as some kind of game, be it computer game, video games, or uh, a game of laws. They're just different types of rules. And the more complex these rules are, the more loopholes you're going to get. You know, let's look at a simple example where you have our tax law, and we know there are tons of tax loopholes. You know, for example, you know the richest man on earth pays less tax percentage-wise than you and I. It's is it fair? Probably not. But you know that's what it is. There's a game of tax laws that we have to go with, and if you're able to find loopholes, you're able to take advantage of it. Similarly, you can have video games where you can also imagine as a set of man-made rules, and even for video games, you can have they can be complex enough that there are loopholes in them. As an example, you know, this is a StarCraft 1 video game that I used to play a lot when I was a kid. And I was actually quite good at it. You know, I was able to come up with creative strategies that take advantage of the game rules, and I would always beat my opponents. And here's a very specific loophole that was discovered, you know, while people play this game. And it was actually leveraging a design decision in the game. I can show exactly what how it looks like. You know, so this player is controlling a unit called probe to try and get past enemy structures. Right? Normally, as you can see, that the terrain should be completely blocked off on the terrain, but somehow this unit is able to build its own structure right next to the structures, and then somehow the the unit itself gets into this floating mode, which allows it to get past the enemy structures, and therefore creating some kind of loophole. And that's just one very specific example. And in general, my research interests in security is therefore studying these various games in our computer systems and networks. Specifically, there are 3 different things that we can do. You know, I'm interested in all of them, but especially the first 2, which are uncovering loopholes in these games. You know, if you have a computer system design, if you have a piece of software designed, you know, they're complex enough, and they're man-made rules, and there are always, like I mentioned, loopholes in them. We wanted to be able to systematically look for these loopholes. And second, we wanted to understand how adversaries can take advantage of these loopholes. You know, if you have a loophole, what can we do with it? What kind of damage can we cause? And finally, once we understand these loopholes and kind of summarize them, distill them into classes of problems, we wanted to redesign the game with better rules, with rules that are unfavorable to the adversaries. Right? So that's really what we do in security, and that's, you know, the first 2 are really my main interests. So let me give you some examples, concrete examples on how the computer system and network games can be broken. Uh, the first example I want to give is about network security. Um, um, what this is showing here is that we have a client and a server, 2 machines that are talking to each other, right? And we have some attacker sitting somewhere on the internet. Now, in the computer world, an attacker can possibly be either sitting on the communication path, in which case we would consider the attacker a man-in-the-middle attacker who's capable of eavesdropping the communication between any two machines that goes through the path. However, in this case, what we discovered is that an attacker that's not sitting on this communication path, and yet the attacker is able to infer, first of all, if these two machines are communicating or not. Any two machines on the internet. And if you tell me their IP addresses, this attacker could infer if they're communicating. And further, the attacker can infer how many bytes or how much data are getting exchanged on this path. And even worse, if the connection is not encrypted, we can inject malicious payload into this connection, either pretending to be the server, sending some responses back to the client, or pretending to be the client, sending some packets or data to the server. Okay, and in the security world, we have this database where we keep track of all serious vulnerabilities, and they're called CVE numbers. In this case, we discovered a vulnerability which was which happened in 2016, and hence the number in the middle. And then there was another number which is just a number indicating which vulnerability it is discovered within that year. So I can show you roughly what we can do with this vulnerability, right? It's actually pretty dangerous because if I, for example, know your IP address, let's say if you're using a smartphone, I can actually tell exactly what website you're visiting at all times. So let's say if the user wants to visit, let's say, a Facebook web page, for example, using the built-in bookmark, but we're able to actually hijack that connection and give you something very different from what should be there. In this case, you can see that the URL is showing m.facebook.com, and that's the real Facebook URL. But all of this can be done with an attacker not eavesdropping the communication and not being a man-in-the-middle attacker. Right? In fact, the attacker can be anywhere on the internet, and as long as we know the IP address of this phone, we're able to launch the attack. Okay, so that's pretty serious. And we have another upcoming work, which is also about network security. And in order for the internet to function at large, we need a lot of internet infrastructure, which is often transparent to users. But what's happening, for example, when you're browsing a website, let's say google.com, your browser is actually issuing a request to this so-called DNS infrastructure, which then would query some servers on the internet to try and get the IP address that corresponds to the URL, to the domain name. So what we can do is we're able to pretend that this is, we're actually able to pretend to be Google's server and then be able to send a response back to kind of fool the DNS infrastructure into thinking that google.com actually points to an IP address that the attacker owns. So in other words, if you type in google.com in your browser, we're able to redirect it to an attacker-controlled server, which is also very serious. Okay, and that's about network security. And I also work a lot on smartphone and system security in general. In this video, I wanted to show you how an attacker can, for example, somehow trick a user into downloading a piece of malware and install it on the right phone. In this case, the malware would be running in the background, and it somehow through a vulnerability, some flaws that we identified on the phone, we're able to track whatever is happening in the foreground app. In this case, a tax reporting app, H&R Block. And let's see how that roughly would work. Oh, and by the way, the left phone here is just to show the attack progress. Whatever the malware running on the background on the right phone would be transmitted to the left phone so that we can see exactly what's going on. All right. So let's say the user is interacting with the H&R Block app, and it's trying to navigate around. And malware in the background can actually tell that the user now is very likely going to view products and services provided by H&R Block app. And it's exactly what the user is doing. And if we continue to allow the user to interact, we're able to track exactly what the user is doing at every step. Okay. And if you notice on the top right corner, there's this My Taxes button. If the user taps on that button, it's going to get redirected to a login page. Okay. And if we slow it down, you can see that there's this normal looking login page. However, when the user enters username and password, they're going to be sent to the attacker phone on here. So this is, what really happened here is that the malware in the background running on the right phone is actually popping up a fake login window at the very right moment, so that when the user interacts or enters username and password, it's actually interacting with the malware application instead of the original H&R Block. Okay. And the final example that I wanted to show is also on the smartphone. And it has a similar assumption where the user has already been tricked into downloading some malware, and the malware further exploits flaws in the operating system so that it can actually dump memory of any other application. It can peek into the memory of any other applications running in the system. And let's see how that would look like. And this is the malware that we developed. It's now doing something, some preparation to drain the system memory. And then it's going to run in the background. Now, if we try to open the Chase banking app, we all do online banking nowadays, probably. And there are tons of sensitive information in our banking account, such as how much money you have, how much you spent on each transaction, and when you made that transaction and where. Right. So if we just allow the malware, which should be running in the background, but here we're just trying to show the result of what it can achieve. It's actually going to be able to print a lot of the details regarding that banking app. As you can see, it shows exactly how much money you spend, how much money you have left in the bank, and pretty much all the details about each transaction. Now, this may sound scary, right? Because there are a lot of security vulnerabilities and flaws in our computer systems and networks. And indeed, our research is looking at a lot of that. But the end goal is not to just find these vulnerabilities, but also we wanted to be able to understand why they happen in the first place. And that kind of drives me into doing more research on the more fundamental question, which is, why do these bugs or vulnerabilities exist in the first place? We want to summarize their root causes. And we even wanted to develop automated solutions to reason about these computer systems and networks and tell you ahead of time, before these systems go live, right, whether there are vulnerabilities. So that's sort of what I'm doing in general in the cybersecurity space.
That's really interesting, and I think it I really like the examples you gave that made it very easy to understand for someone like me who's not necessarily an expert on this topic. You mentioned, I know you talked about network security. Can you expand a little on that? It seems like every time we turn around, another network has been hacked and data has been stolen. Can you talk a little bit more about what you're doing to protect networks like the one we're on right now?
Right, right. So I guess as I mentioned, anything man-made which has a decent, which has a complex enough set of rules would have loopholes, and networks are no different. And what's worse, these networks, are evolving over time. We have newer protocols that are designed. We have new applications getting developed, and so on. And so, in order to not play a whack-a-mole game, we have to stay ahead of the adversaries. So, as you mentioned, the reason that we see a lot of these networks getting hacked today is because we are behind. We're not staying ahead, and research would ultimately allow us to understand these different types of loopholes, why they occur, what forms, in which forms they would occur, and ultimately we wanted to be able to develop automated solutions that can reason about these networks and applications, so that before we deploy them, we already have some confidence that they are already they're secure enough to be used in practice. Unfortunately, we're not there yet.
What do you consider most important about your research?
I think cybersecurity in general is an area that touches pretty much everyone's life nowadays. As I just showed in my research interests, everybody has a smartphone, and you have a lot of sensitive data on the phones. And if you get hacked, obviously sensitive information can be stolen: your username, password, banking accounts, and social security number, credit card numbers, and so on. And not just at our individual level, but also at the corporate level and even the government level, they have much higher stakes. So I think pretty much everybody at every level in our society is affected by cybersecurity, and that's what makes it really, really important.
What is there anything we can do to safeguard our upcoming election from a network security standpoint?
I guess I'm not an expert on election security or electronic voting security. I know there are people, researchers working on this area, and from my understanding, they're not so different from any other computer system. It's just a different game of it's just a different game with a different set of rules. And when you understand those rules, you will be able to find loopholes. And I know researchers who have analyzed voting machines, for example, and discovered many different security flaws. And what concerns me is that these voting machine vendors are not necessarily security experts, or probably they haven't hired enough experts. And this is why people often argue against any form of electronic voting, and simply prefer the plain and simple paper ballots. And I tend to agree with that. Unless we have a high enough confidence on the infrastructure of the voting systems, I would personally not advocate or prefer the electronic version.
Yeah, I prefer paper too. I'm glad that we mostly do paper ballots in California. So related to this, is there anything we can do as consumers to safeguard our data?
I guess there are quite a number of standard things we can do. For example, when you get an email, not sure who's sending you that email, and it has maybe some links. Don't try to click on those links that you don't recognize, because they can lead to many sorts of dangers. First of all, it can be a phishing attack by pretending to be a banking website. And if you enter your username and password, you're basically giving them away. And secondly, it could trigger an automatic download and installation of a piece of malware onto your system, which can then further compromise your whole system and taking control over your machine. So that's pretty dangerous. And in addition, if you have a smartphone, don't download apps from untrusted sources. Don't stay on web pages that look shady. For example, with a lot of pop-ups. Um, and here's something more advanced. If you have some file or some data that you must look at, or you must open, but unsure how safe it is, you can actually turn on a virtual machine and open it there. That way, even if it's compromised, even if your virtual machine is completely compromised by that the file that you open, you can just throw away the virtual machine without affecting your main operating system. And even better, you can take a snapshot of the virtual machine, open that unknown file, do whatever you want with it, and then revert the virtual machine back to the snapshot as if nothing has happened. So that's a slightly more advanced trick that people are not always familiar with, especially for non-technical people.
That's a good one. I didn't know about that, so I'm interested to learn. I'm not sure I could set my computer up that way, but I'm glad to know that it exists. What are your future plans for research, moving into being an endowed chair?
I guess my main research interest, as I mentioned, is about studying different computer system and network games, or in our terminology, we call it vulnerability discovery and analysis. So this involves distilling the kinds of loopholes, the kinds of flaws into different types, and then reasoning about each type, and look for them in a given system, in a given game. So that's my main interest, and I wanted to still continue doing that. But I'm also very much interested in expanding my research, in particular, incorporating machine learning and AI-based solutions into that reasoning process. And this is because the more precise way of reasoning that we used to apply, right, all these years, have serious limitations now, and we realize that they're they won't be able to scale, for example, the very large and complex systems and rules. And so if we look at how human experts overcome some of these challenges and limitations, they often form intuitions and hypotheses about what might happen. And that is very valuable, and maybe something that can be learned and extracted using machine learning and AI. So that's something that I'm very much curious to get into, but I haven't really done a lot.
Well, it sounds like this might provide an opportunity for you to explore those new pathways a little bit more.
Yep, definitely.
Well, I think we're ready to start taking questions. Are there any questions? Okay, I see one. How does the vulnerability of cybersecurity in other countries jeopardize the system as a whole, affecting the US and the rest of the world?
That's an interesting question.
Mhm.
So I guess we are in an era where the world is pretty much connected, not so much as the current trend is going in the US, but by and large, the world is very much connected, and we build our system and software on top of each other. For example, somebody would build an open source, let's say, browser, Chrome or Chromium, for example, and they get leveraged by other companies, right, for example, to put into a smartphone operating system, and they package that entire smartphone as a product to sell to the user. So we have a lot of reuses of components of either hardware or software, and if you have vulnerabilities in those components that you don't directly control, that's going to backfire at some point. So this question is exactly on spot, in the sense that we have a supply chain problem where if you don't have the capability to verify and to analyze the systems and the hardware and software components that you reuse or borrow from others, then you definitely run the risk of getting your own system compromised at some point. So I would say it's not just affecting the US or any other country. This is a global problem.
What is your long-term prediction? Can we or should we trust smartphones eventually, or will it always be a catch-up game? And related, is there any difference between Android and iOS from a security point of view?
That's also an interesting question. Smartphone. I've been working on smartphone security for quite some time now. I guess it fundamentally smartphone security is not so different from any other like any operating system like Windows, Linux that we were using on a regular basis. In fact, the smartphone operating systems have more security features than our desktop or PC operating systems, and they are, in my opinion, more secure. However, like I mentioned, anything that's so complicated, uh, with millions and millions of lines of code to be able to build a smartphone operating system, and not to mention the applications that are on top. There's so many loopholes that are just lurking out there, and it's really hard to get rid of them ahead of time. But again, that's why we're in this business of researching in the cybersecurity space. There are so many things that we're doing now to try and improve the situation. And I believe over time we are going to get a more and more secure system for our smartphones or otherwise. I guess I'm not sure exactly when we'll be able to see a day where we can say, okay, I am 100% or even 99.9% sure that I'm not going to get malware or compromised, anytime soon. So, and I guess that other question about Android and iOS, I am mostly an Android user, and I do a lot of research on Android myself. My sense is that Android initially has a lot of security problems, but Google has really done a good job in the past to kind of improve the security posture. So it's actually getting harder and harder to find serious flaws in Android. And I guess for iOS, it is sort of a similar situation, but perhaps it started out as a platform that's already somewhat more secure than Android. But by this point, I would not consider them fundamentally different. They're more or less the same.
That's reassuring because I have an Android, so I'm glad to hear that it's getting better. Okay, we got another question here. Do you think quantum computing can be a cybersecurity threat?
That's an interesting question. I don't personally do research in quantum computing. I know uh, the crypto implications of quantum computing, um, and that has to do with the mathematical assumption that we make when we design these crypto algorithms. Um, you know, if we're able to build quantum computing machines, then we are able to break a lot of these mathematical assumptions. And therefore, yeah, I guess we would have to at least redesign those crypto algorithms at the very least. Um, but but in general, we still have this, this legacy problem of software application, operating system networks. They still have the more traditional kinds of security flaws that we have to worry about. And quantum computing just adds another layer of complexity.
Okay, that's good to know. Here's an interesting one. Are you or UCR involved in studying vehicle security? If so, please elaborate.
Yeah, we do have some researchers at UCR, and I'm also personally involved in one project at least uh, um, on vehicle security. So yes, I guess so. The team involved professors from ECE, mechanical engineering, and NCS. So we were studying um, uh, various issues with communication, because in in the people envision that vehicles don't just drive by themselves; they actually talk to each other to coordinate in terms of how they drive, to save energy and so on. Um, and if whenever they communicate, they would, there would always be this trust issue where, how do you know that the vehicle next to you is telling you the truth? For example, that it's there's some obstacle in front of that vehicle. How do you know? Um, and and also timing is a very sensitive issue in that context, because cars are driving very fast, and if you have to rely on other vehicles' messages to make a decision on what you want to do, it can be very dangerous if you receive that message too late. Right? So we're kind of looking into those angles in particular. But I'm sure there may be other efforts going on as well that I may not be fully aware.
Um, Children now have smartphones and have access to computers. How worried should we be about this where cybersecurity is concerned, given how interconnected we all are?
That's a very good point. Um, Cybersecurity, as we mentioned, is um, it's very complex, and there are a lot of tips that we can follow as regular users, non-technical users. But if you have, for example, kids, or if you have elderly people, they may not be able to understand what they should do to prevent, for example, their smartphones from downloading a piece of malware, for example. Um, and that can indeed create problems. For example, a lot of the machines, nowadays, I don't know, on average in a single household, how many different electronic devices we have on average. I think in my home it's probably more than 10. Have phones, iPad, computers, laptops. My wife has them, and so on. And if one of the devices is compromised, it could also potentially compromise your other devices in the same household. So indeed, if you have a weakest link in your home, then it could jeopardize your other systems. And I guess that's why education is still a major role. It plays a major role in actually overall in securing our systems. It's part of the playbook.
Aren't there any certification authorities, say analogs of the CDC, that could certify software to be secure, at least in some limited way?
That's an interesting question. You would think so. Unfortunately, what's happening in practice is that you can have any kind of authority, any kind of technique that they would apply, either by manually inspecting your source code, or maybe run some sophisticated analysis, automated analysis on the source code or the program binaries. They can provide certain level of confidence on that software, but there's no way that they can say with 100% certainty that a piece of software is secure. In fact, we know that from the very fundamentals of computer science, to be able to prove any reasonably complex property, such as a lack of certain types of errors in a software, is NP hard. I guess that's a technical term, which basically means it's impossible to determine that if a piece of software is bug free or vulnerability free in some limited amount of time. So we already have this impossibility result. But yeah, I guess the question is that, can we still try to do certification? I guess we can, but then it's going to be very limited, and probably people are not going to trust it anyways. So it's, as far as I know, there's even if they exist, perhaps I'm not aware of them. Even if they exist, they're not really taken seriously.
Right. How can colleges and universities better prepare students who pursue careers in information technology to do a better job in guarding our networks and databases?
Right. Yeah. So that's as far as I know, cybersecurity is an area where we have a big gap between demand and supply. Right? I think there are tons of job opportunities out there, and we have a lot of cybersecurity programs all across the country. But I guess it's also important to realize that security as a field is largely driven by interest. As I mentioned earlier, we really need to have this adversarial thinking or adversarial mindset to be able to get into the field more deeply. So based on my experience interacting with students, oftentimes it's those students who have this mindset of adversarial thinking would be able to do well eventually. So I think it's important to kind of educate our students, pick those students that are really, that already have this kind of adversarial thinking, or even better, if they don't come with this adversarial thinking, we wanted to kind of see if we can get them into that mindset. And then I think things will happen naturally. These students would become perhaps researchers like me in the future. But I think that interest is really the key in getting people into the security field in college and universities.
I think I want to go back to something you mentioned earlier about how you were really good at playing these computer games when you were a kid because you could find the loopholes and take advantage of them. Do you think that's a kind of, what role do you think computer games play in cultivating that adversarial kind of thinking and curiosity that will maybe help build, a future generation of security engineers?
Right, that's interesting. So I personally, obviously I cannot speak for others, but my personal experience is really, um, I think I benefited a lot from playing the video games. I don't want to say that it's a good thing that everybody should play video games and get addicted perhaps, um, uh, but I do feel like if you play video games, at least it's a way it's a way of kind of getting you trained into that adversarial thinking. Because obviously when you play a game, especially a competitive game, you have your opponents. You have to come up with strategies. You have to kind of identify what are the critical rules designed in the game, and you have to find ways to kind of take advantage of them in order to beat your component and ultimately win the game. So I think it's maybe one of the ways that you can get trained into this adversarial thinking, but it probably is not the only way. It worked great for me, but uh, there may be other paths.
On that note, we have time for probably about one more question, and it's a good one. What is your all-time favorite video game?
StarCraft, as I used, as an example in my slides, because I think it's a very competitive game. You have to think in real time about the decisions that you want to make, and there are so many things you can choose to do. So the decision space is huge, and you have to make quick decisions. Those are the two factors that make it very, very interesting and attractive. It's a very open-ended game in some sense, because there's so many possibilities.
Well, I guess actually we have time for one more that should be pretty easy. What careers are most promising for your students?
Sorry, career.
Yes, career. What careers are most promising for your students?
Oh, I guess if we're talking about PhD students, I think they are. I spend a lot of time training my PhD students. Um, uh, I think ultimately they would become security experts or researchers just like myself. I believe they have a lot of options these days, from academia to industry. I personally would hope that my students would be able to become a professor like me, and and I think these jobs are very promising. There are a lot of, as I mentioned, there are a lot of demand to train the next generation professionals in security, and we know that there are also a lot of positions, faculty hiring going on, as one of the top priority in computer science departments across the country. Of course, pre-COVID, nowadays, things are completely different. But also industry-wise, we have a lot of opportunities as well, ranging from research positions in industry labs, for example, and engineering or positions developing cutting-edge security products. I have two students graduated who both joined Google so far, and they focus on building security products. But I also have students that haven't graduated, and some of them are interested in becoming a professor. I think that's wonderful. Some of them are interested in getting to the research lab, doing research, even though not in an academic setting. But there are a lot of options nowadays. I think they're all promising, in my opinion.
All right, well, I think we're pretty close to time. I want to leave you with one comment from the audience that StarCraft is awesome and they're glad you like it too.
Thanks.
Are there any more questions or is there anything else you'd like to talk about?
No, I guess that's a very good run.
Yeah, all right. Well, I think we don't have any more questions and it's been great talking with you. And I'm excited for the work that you're going to do with your new endowed chair funds.
Cool.
Thank you.
Thanks a lot.
Thank you, Holly and Professor Qian, and thank you to everyone who joined us this evening. This concludes our webinar. Have a good evening.